Let's review over chapter 4. This first example says, in a circle with a radius r, a central angle theta intercepts a chord of length c. And then we're giving this formula right here. So let me get my pen working. Given this formula right here. All right. So it says an airplane that is 2,646 feet flies directly over a gun. Has a range of 2,730 feet, as shown here in this diagram. What is the measure in degrees of the angle for which the airplane is within the range of the gun? And it's in Pythagorean theorem. So we know the Pythagorean theorem is a squared plus b squared is equal to c squared, but let's let a be the h, which is the height. And you can call b c for the chord, or you can call it x, whichever one you want. And let's call c here our radius. Well, we know what the height is. It's 4,600. And we're going to square it, or 2,646. Plus c squared is equal to our radius, which is 2,730. We square it. Let's solve for c squared. When we do that, I'm going to subtract this from both sides. Y'all can go ahead and compute the number, or you can wait and do it at the end. So now I got 2,730 squared minus 2,646 squared. And then I'm going to say, oh, okay, I need to square root both sides because I want c. So I'm going to square root both sides. And now I have c is equal to, and let's crank this out in our calculator, square root 2,730 squared minus 2,646 squared gives me 672. Now, we have two parts of this chord, so that means I'm going to add c to itself again. And when I do that, I get 1344. Now that I have done this, I'm able to plug everything in my formula. We'll scroll down just a little bit. So the formula that was given to us, theta is equal to cosine inverse of 1 minus my c squared divided by 2 times my radius squared. Okay, so let's just plug in what we know. My c squared is 1344, and my radius is 2730, which is 2,730. All right, so now I'm going to round to the nearest tenths when I calculate this. Make sure you're in the right mode in your calculator. It said degrees, so in the question, so make sure you're in degrees mode before we get started. Cosine inverse of 1 minus that fraction. And I get approximately 28.5 degrees. Now let's go to our next example. Our next example says that we have to find the angles in degrees that satisfy the following. So you're given this, and you're asked to fill in the blanks here. Okay, so let's do that. We know this information here is given to us. This is something that we know from our identities. So, or not our identities, our solutions. So let's solve this. What I need is get sine alpha by itself, and then I'm going to get alpha by itself. So first things first, I need to subtract this 1 from both sides, right? Now I got 2 sine alpha is equal to -1 divided by 2. Now I got sine alpha is equal to a -1/2. Take the inverse of sine. And now that I've taken the inverse of sine, let's put it in our calculator again. Make sure you're in the right mode. Each question may ask for something different. So it gives me a -30 degrees. All right, we're almost there. So we got to figure out what happens here. So it said that we are using this formula, whoops, right here, because S is less than 0, meaning it's a negative number. We had a negative half, so we know we're using this. So let's plug it in. Now, in order to do this, I need to determine each side. Since it's a negative value, we went clockwise, so let's do this. I got 360 degrees minus that 30 degrees gives me 330 degrees. So now I know what goes here. Now let's find the other one. The other one, I'm going to take 180 degrees and I'm going to subtract the negative 30 degrees, which means we're going to end up adding, right? Gives me 210 degrees. So that's what goes here. Okay. Let's do our next example. Our next example says find all real numbers in the interval of 0 to 2 pi. So make sure you're in radians, and I'm doing that right now while we're talking. And that satisfies this equation. So we got a little bit of work to do. You notice that we got a lot going on around sine x. So I got 2 sine 2x is equal to, or excuse me, minus that square root of 2 is equal to 0. Let's add the square root of 2 both sides. So now I got 2 sine 2x is equal to square root of 2. Let's divide by 2. Now I got sine 2x is equal to square root of 2 halves. And now let's take the inverse. So I got 2x is equal to sine inverse square root of 2 halves. And when I do that, and in radians mode, I get pi fourths. Now going back to those equations we had before, based upon if s is greater than 0 or less than 0, we know what we're going to be working with. So in this case, it's greater than 0. So we're going to work with the set that builds on x is equal to s plus 2k pi, and x is equal to pi minus s plus 2k pi. So let's plug in. My s is pi fourths plus that 2k pi. So this is one answer. If it asks us for the exact value, then plug in for k equals 0, k equals 1, k equals 2, and you have some values. This one here is pi minus that pi fourths plus 2k pi. And let's see. Oh, and guys, I left off a step. I hope that you caught this. What happened? I should have changed the coloring here. It was 2x and not just x here. So I have some work to do. This is not completed, okay? So I'm going to come down here and say, oh, okay, now I acknowledge this. I caught my, whoops, that's over 4. I caught my typo right quick. All right, now let's go over here. Don't forget, this is going to be 2x is equal to. So I got pi minus pi fourths. So I got 3/4 pi plus 2k pi. Okay, so now in order to finish, I got to, oops. It's not going to let me do this. So let me come back up here and write it in. 2x equals pi fourths plus 2k pi. 2x is equal to 3/4 pi plus 2k pi. And I'm going to erase this right quick. All right. Now here we go. I'm going to divide by 2, divide by 2, divide by 2, divide by 2. All right. Now I have x is equal to pi fourths divided by 2. Remember, I got a fraction going on, so we keep change flip. So this becomes pi fourths times that 1/2 plus 2k pi. Oh, what happens? 2 divides 2 is 1. 1 times k pi. So now I have pi 8ths plus k pi. That's one of my answers. Now I got 3 pi 4ths divided by 2. And again, keep change flip. So now I got 3 pi 4ths times 1 over 2, which is 3 pi 8ths. And then we divide by 2 on this other side, and we get plus k pi. Again, this is our answer. If it asks us for exact values, plug in for k. Now let's do this next one. This next one said that we have sine squared x is equal to 3/4. We're on the interval of 0 to 2 pi. So again, we're in radians. Make sure you're in that. So let's solve for the sine, and let's get the x value because we're trying to figure it out. So in order to do that, I need to square root both sides. So now I got sine x is equal to square root of 3 over square root of 4, which clean it up becomes sine x is equal to square root of 3 over 2. Take the inverse of sine. And when I take the inverse of sine, it's a plus or minus, guys. Since it's an even root that we're taking on both sides, we get a plus or minus. So go to the unit circle. And everywhere is on the unit circle that you see for sine, square root of 3/2 for sine. We're not looking at cosine. We're going to get some value, right? Some radian, something going on. And that's what it's asking for. So our slit here is 5/3, 5 pi thirds, 4 pi thirds, 2 pi thirds. So just, if you have the unit circle memorized, this will help. If not, you will need to look at it, practice it a little bit more. So let's see if I can make some more room. All right, let's finish this up. It says that we have 4 sine squared theta plus 4 sine theta plus 1 is equal to 0. And what is the solution set? And we're in degrees mode, and we fall between 0 degrees and 360 degrees. All right, so there's multiple ways to do this, but the first thing I want to do is substitute something in. I'm going to let y equal my sine theta. If I do that, now I got 4y squared plus 4y plus 1 is equal to 0. And now I'm going to look at it and I'm going to factor it down. Well, I know 2y plus 1 times 2y plus 1 will give me back that. If you're unsure, just do the full method. So we got 2y times 2y plus 2y times 1 plus 2y times 1 again. So I got the first of each parentheses, I got the outers of each parentheses, I got the inners of each parentheses, and now the last. So I got 1 times 1, check. It's going to give me back what I started with. So now I can rewrite this as this, right? It's the same parentheses. So this is just all notation. So I'm going to focus what's inside it. I got y plus 1, or 2y plus 1 is equal to 0. Let's solve for y. And then divide by 2. All right, so now I got y is equal to a -1/2, and let's plug in what I know for y. Sine theta. Now let's take the inverse of sine theta. And the inverse of sine at a -1/2 gives me -30 degrees. So I know that I'm going to say 180 degrees minus that -30 degrees means I'm going to add it, gives me 210 degrees. And I'm going to say 360 degrees minus that 30 degrees, which we would have added the negative value of it, gives me 330 because we can't go above 360. It gave us an interval to stay within. So my answer is 210 degrees and 330 degrees.